Welcome back. Let's get into it. So today we're going to be looking at trigonometry. So this is a lecture series. So we're going to have 4 episodes of the series. So in the first episode though, we're going to look at the trig fundamentals, where we will revisit the Pythagoras theorem. We're going to look at the trig ratios and identities. And finally, we're going to do the examples. So just make sure you tune in for the other episodes as well. All right. So let's get into it. So imagine you have a Cartesian plane so in this Cartesian plane, we have 0, 90, 180, 270. So on this plane, suppose there's a point here, right? Let's call this point P, and it has coordinate X and Y. This point P is inclining at angle theta from the axis 0. So because point P has coordinates X and Y, therefore we can define our triangle as being a right angle triangle with this side being a Y and this side being an X. And therefore the longest distance, we'll call it R, which represent the hypotenuse. So what the Pythagoras theorem state in mathematical form is that the squared of the hypotenuse is equals to the sum of the squared of each side. So meaning the sum of the squared of X and the squared of Y. So in essence, that's what Pythagoras mean. Okay. So right, let's move on to look at Pythagoras, look at the trig ratios. Okay, so trig ratios, in this episode we are talking about the sine of theta, the cos of theta, and the tan of theta. Okay, so by definition we know that sine of theta refers to the opposite over hypotenuse, whilst cos means the adjacent over hypotenuse. Tan theta means the opposite over the adjacent. Okay, so now all that we need to do is to let's compute this in terms of this triangle over here. So we'll have sine of theta being the opposite over hypotenuse. We know that the opposite of this theta refers to the y, and therefore opposite will be y over the hypotenuse r, so it will be y over r. And then the cos theta will be adjacent, which just means the side next to the angle in question, which is theta, so it will be x over the hypotenuse r. Tan would be y over x. So these in this episode are the trig ratios that we're going to be focused on. Okay, so now we're going to look at the trig identities, right? So trig identities, we have 2 that we're going to be focused on, and the first one is the quotient identity. Okay, quotient identity is the tan of theta equals to the sine of theta over the cos of theta. To compute this, we now have to put this in this trig ratios, right? So we know that the sine of theta, according to this over here, let me use a different color. So the sine of theta is y over r, right? Divide by the cos of theta. Cos of theta is x over r, so it will be x over r. Then we therefore know that r will cancel r and we'll be left with y over x. But we know that according to these trig ratios, y over x equals to tan theta. Okay, so that's how we are able to prove the quotient identity. So the second identity that we're going to be looking at, is called the square identity. So number 2, I'll call it the square identity. Okay, so the square identity, it states that the square of the cos theta plus the square of the sine theta equals to 1. So to prove this, all that we need to do is to take the left hand side, this left hand side, right, which is our left hand side, and say that according to the trig ratios, we know that here cos theta is x over r. So we'll have x over r squared plus sine theta is y over r. Then we'll have y over r squared. And then we simplify in the sense that we'll be left with, after simplifying, we have r squared divided by x squared plus y squared. But I need you to notice something over here. This here, according to Pythagoras, is actually r squared. It's this here. So r squared is equals to x squared plus y squared. Therefore your y, your x squared over here, therefore your x squared plus y squared over here becomes r squared. Okay, therefore we can write it as r squared over r squared. They cancel each other, they give you 1. Okay, so this is our first example that we're going to look at, which says simplify the cos theta squared times tan theta plus tan theta times sine squared theta. So to simplify this, we notice that there's tan here, there's tan here. Therefore, we can take our tan of theta as our factor, where we are left with cos squared theta plus the sine squared theta. Okay, and we know that the square identity says that the square cos squared theta plus sine squared theta will give you 1, and therefore we're able to, and therefore our answer becomes tan theta, because this here is 1. Okay, now let's move on to example number 2. Okay, so let's do example number 2, which says simplify this expression, right? So let's just write it down here so that everybody is able to see, where you have your 2 tan b cos b sine b all divided by square root of cos b minus 1. So we're going to use trig identities, right? This is a quotient identity, so we'll put in 2 times a sine of b over a cos of b multiply by a cos of b multiplied by a sine of b, and all divided by this here is a trig identity. Remember that trig identity? It said that's the square identity, which says that cos squared plus sine squared equals to 1. So in this case, we have 1 on the side, so we have cos squared minus 1 equals to minus sine squared. And therefore, we can replace this by a minus sine squared of b. Okay, so cos b and cos b cancel, and we have a sine of b times the sine of b. So we'll be having 2 times sine, that will be sine squared b over minus sine squared b. Therefore, sine squared b and sine squared b will cancel. Then we are left with a minus 2. That's our final answer. That's it for this first episode. So be sure to tune in for the next other episodes that we're going to be looking at.